How are you doing, dear friends of my YouTube channel, Learn Maths Iga Imibale? Now we have a question to evaluate. Okay, we need to evaluate the value of this stuff. Okay, let's do it together till the end. Let's assume z1 to be this 1 plus, because this and this forms one little part. We have cosine pi over 8 plus I times sine pi over 8. We know that for z, which is a plus bi, its modulus is the square root of the square of this plus the square of this, and the argument of this z may be written as the inverse tangent of b over a. Okay, now let's find the modulus. Okay, the modulus of z1, as you see here, is the square root of, we need to take the square of this 1 plus cosine pi over 8 power 2 plus the square of this sine square of pi over 8. Okay, explain me this. This is the square root. The square of this is 1 plus 2 times cosine pi over 8 plus the square of cosine pi over 8. Then plus here is square plus the square of sine of pi over 8. Here the modulus of z1 is equal to, as you see here, from fundamental trigonometric equation, this gives 1, and you have this 1 plus this is 1 plus 1, this is 2 plus 2 times cosine of pi over 8. This is, you have the square root 2 into 1 plus cosine of pi over 8. Okay, from linearization formula, we know that 1 plus cosine theta, this is 2 times the square of cosine theta over 2, while 1 minus cosine theta, this is 2 times the square of sine of theta over 2. Now, as you see here, this modulus will be the square root of 2 times 2. Here is 2. We are going to apply this formula. This is 2 times the square of cosine this angle by 2. This is pi by 16. So the modulus of z1 is equal to 2 times cosine pi by 16. Here is the modulus of z1, and the argument of z1 is equal to, we take this and divide it by this. We have an inverse of sine pi over 8 over 1 plus cosine pi over 8. Okay, this is the inverse tangent of, we have transform this in double angle formula. We have 2 times sine pi by 16 times cosine pi by 16 over, we saw this is equal to this here. This is 2 times the square of cosine of pi by 16. Now we need to simplify this and this square and this cosine. Argument of z1 is equal to tan inverse, the inverse tangent of sine of pi by 16 over cosine of pi by 16, that is tan of pi by 16. So this inverse and this tan need to cancel one another. We have argument of z1, this is pi by 16. Okay, let's write it here. Now we saw the modulus of z1, that was 2 times cosine pi by 16, and the argument of z1 is pi by 16. Now let's continue with z2. Let z2 be this. z2 be 1 plus cosine pi over 8. That's why this and this form your part minus I times sine pi by 8. Now the modulus of z2 is equal to the square root of, we have 1 plus cosine pi over 8 for 2 plus this is minus sine pi over 8 for 2. As you see, this is the square root 1 plus cosine of pi over 8 for 2 plus sine squared of pi by 8. You see, this is the same as what we had. z2 modulus is equal to, it's the same as the modulus of z1. This is 2 times cosine pi by 16. What about the argument of z2? Let's look for the argument of z2. This is an inverse of, we have this stuff times minus, this is minus sine pi over 8 over 1 plus cosine pi over 8. The only difference is that here is minus, otherwise it should be the same. Now argument of z2, this is an inverse. As we did in our previous, we transform this into double angle. We have minus 2 times sine pi by 16 times cosine pi by 16 over 1, and we saw this was 2 times the square of cosine pi by 16. Okay, now we need to simplify this and this. This is square and this stuff to stay with argument of z2, which is an inverse of sine over cosine, that is tan, this is minus tan of pi by 16. Okay, so z2 is, we know, tan of minus theta, that is minus tan theta. So this is an inverse of tan minus pi by 16. Okay, so we need to simplify this tan inverse and this tan to stay with argument of z2, which is minus pi by 16. Okay, yes, let me write it here. Okay, we have this modulus and we have this argument. The z2 modulus is 2 times cosine pi by 16, while arg of z2 is minus pi over 16. Now, having z, which is z1 over z2, in trigonometric form or exponential form, z can be written as the modulus of z1 over the modulus of z2 times cosine of argument z1 minus argument of z2 plus I times sine of this stuff. We have arg z1 minus arg z2. Okay, this is created. This z, let me write it here. Here z will be the modulus of z1 is this. This is 2 times cosine pi by 16 over the modulus of z2, which is the same, 2 times cosine pi by 16. You know, this gives 1 into cosine. Argument of z1, this is pi by 16 minus, as it is here, minus pi by 16 plus I times sine pi over 16 minus pi by 16. Okay, this z is equal to, simplify this and this, we have only cosine. This is pi by 16 plus pi by 16, that is 2 pi by 16, which is pi by 8 plus I times sine pi by 8. So because all this stuff is assumed to be z, we need to find the z power 8. From DeMoivre's theorem, we know that cosine theta plus I sine theta power n. This is cosine n times theta plus I times sine n times theta. So our z power 8, I mean this stuff, z power 8 is equal to cosine pi over 8 plus I times sine pi over 8 all raised to 8. Okay, this is equal to cosine of 8 pi over 8 plus I times sine 8 pi over 8. As you see here, we need to simplify this 8 and this and this. So z power 8 is equal to cosine pi plus I sine pi. You know, sine of angle pi, this is 0, but cosine of pi, this is minus 1. That is to say, all of this value tends to minus 1. This is the answer to the given question. Thank you very much for watching, and before leaving, I want you to subscribe on my channel. Your like, your share, your comment are very important. Don't forget to help me, please.